Picture yourself staring at the computer screen as 75,000 years of climate data unfolds before your eyes. The graph shows something terrifying. The period when bone tool technology exploded across human populations coincides exactly with the onset of the most catastrophic climate event in human history. This is the Toba supervolcanic eruption, Dr. Turney explains, pointing to a massive spike in the data that marks the moment everything changed. 74,000 years ago, this single event nearly drove our species to extinction. The volcanic winter that followed reduced the global human population to perhaps as few as 10,000 individuals. But somehow, our ancestors survived, and bone technology is the reason why. You're looking at the moment human ingenuity saved our species from extinction. The Toba eruption represents a catastrophe so vast that it defies comprehension. The volcanic blast was heard across half the planet, ejecting enough material to bury the entire state of California under 3 feet of ash. But the immediate explosion was just the beginning. The real catastrophe came from the atmospheric effects that followed. Dr. Michael Rampino from New York University has spent decades studying the Toba event and its effects on early human populations. His research reveals the full scope of the disaster that our ancestors somehow survived. The Toba eruption ejected approximately 2,800 cubic kilometers of material into the atmosphere, Dr. Rampino explains, showing computer models of the volcanic winter that followed. That's enough ash and sulfur compounds to block sunlight across the entire planet for 6 years. Global temperatures dropped by at least 3 to 5 degrees Celsius, and in some regions, by as much as 15 degrees. Picture the world that our ancestors faced after Toba. Perpetual twilight, as volcanic ash blocked the sun temperatures that turned tropical regions into Arctic environments, and a collapse of plant and animal life that eliminated most food sources across the globe. This wasn't just climate change. This was an ecological apocalypse that should have ended human civilization before it began. The ice core data reveals the full scope of the catastrophe. The volcanic winter that followed Toba lasted for at least 6 years, with reduced sunlight and altered weather patterns continuing for decades. Global precipitation patterns collapsed, ocean temperatures plummeted, and the atmospheric chemistry was altered in ways that made the air itself difficult to breathe in many regions. Dr. Stanley Ambrose from the University of Illinois has studied the genetic bottleneck created by the Toba catastrophe. His research reveals that the human population crashed so severely that all modern humans descend from the tiny group of survivors who endured the volcanic winter. The genetic evidence is unambiguous, Dr. Ambrose explains, showing DNA analysis that tracks human population bottlenecks. The entire human species was reduced to perhaps 10,000 individuals scattered across the globe. In some regions, the population may have dropped to fewer than 1,000 people. We came within a hair's breadth of complete extinction. But here's where the story becomes incredible. Archaeological evidence shows that while other human species struggled and died during this catastrophic period, the populations with advanced bone tool technology not only survived, they thrived. They used their bone needles to create clothing warm enough for the new ice age. They used bone harpoons to exploit aquatic resources when land animals disappeared. They used bone implements to process the few plant foods that remained available. The survival advantage provided by bone technology was so significant that it fundamentally altered the course of human evolution. The populations that possessed sophisticated bone working skills had access to resources and survival strategies that were simply unavailable to groups without these technologies. Dr. Curtis Maureen from Arizona State University has spent decades studying human survival during the Toba catastrophe. His research reveals something extraordinary. The human populations that survived this near-extinction event all share one characteristic. They had developed sophisticated bone tool technology before the disaster struck. Bone tools weren't just useful, Dr. Maureen explains. examining artifacts from the crucial survival period. They were the difference between extinction and survival. The populations that had mastered bone technology had the adaptability to survive when the world ended around them. The archaeological evidence from post-Toba sites reveals the crucial role that bone technology played in human survival. Clothing production using bone needles allowed humans to survive in regions where temperatures had dropped below the tolerance range for unprotected human physiology. Bone fishing equipment provided access to aquatic protein sources when terrestrial animals were dying from starvation and cold. Bone processing tools allowed extraction of nutrients from plant materials that would otherwise have been inedible. Dr. Marine's excavations at Pinnacle Point in South Africa reveal one of the most important survival refuges from the Toba period. The cave contains evidence of continuous human occupation throughout the volcanic winter, with bone tool assemblages that show rapid innovation and adaptation to changing conditions. What we're seeing at Pinnacle Point is survival innovation in real time, Dr. Marine explains, showing bone tools that display rapid technological evolution during the crisis period. As conditions deteriorated, the toolmakers didn't just maintain their existing technologies. They improved them, adapted them, and created entirely new categories of implements designed specifically for survival in the post-Toba world. Picture the scene. Volcanic winter has turned the world into a frozen hellscape. Most animals are dead or dying. Plant foods are virtually non-existent. But in scattered refuges around the globe, small groups of humans huddle around fires, using bone needles to create layered clothing systems, bone fish hooks to catch the last remaining protein, bone scrapers to process every scrap of available food. The bone tools from this period show evidence of desperate innovation driven by survival necessity. Needles become smaller and more precise to work with limited materials. Fishing implements become more specialized as aquatic resources become the primary protein source. Processing tools develop features specifically designed to extract maximum nutrition from marginal food sources. Dr. Allison Brooks from George Washington University has studied the technological adaptations that allowed humans to survive the Toba winter. Her research reveals that bone tool innovation accelerated dramatically during the crisis, with new tool types appearing every few hundred years as conditions continued to deteriorate. The pressure for innovation was extraordinary, Dr. Brooks explains, showing tool assemblages that spanned the volcanic winter period. Every generation had to solve new survival challenges, and bone technology provided the flexibility to create new solutions faster than any other available technology. But the revelation goes deeper. Dr. John Hoffaker from the University of Colorado reveals that the genetic bottleneck created by the Toba catastrophe had an unexpected consequence. It accelerated human evolution. The survivors weren't just lucky, they were selected for intelligence, cooperation, and technological innovation. The selective pressure was so intense that it fundamentally altered human cognitive capabilities within just a few thousand years. The survivors weren't just the ones with the best bone tools. They were the ones with the mental flexibility to innovate, adapt, and create new technologies under extreme stress. What we're seeing is evolution in real time, Dr. Hoffaker explains, showing genetic data from post-Toba human populations. The catastrophe eliminated populations that couldn't adapt quickly enough, leaving only the most innovative, cooperative, and technologically advanced humans. The bone tool makers didn't just survive, they became the founders of all subsequent human civilization. The genetic analysis reveals that the cognitive traits we consider essentially human abstract thinking, long-term planning, technological innovation, complex cooperation all show evidence of rapid evolution during the post-Toba period. The crisis didn't just select for physical survival, it selected for the mental capabilities that would define our species. Dr. Richard Klein from Stanford University has studied the archaeological record before and after Toba. revealing a dramatic acceleration in technological and cultural innovation following the volcanic winter. The pace of change increased by orders of magnitude, with new technologies appearing every few generations instead of every few millennia. The Toba bottleneck created a cognitive revolution, Dr. Klein explains, comparing pre- and post-Toba archaeological assemblages. The survivors weren't just more skilled, they were mentally different, with enhanced capabilities for innovation, cooperation, and cultural transmission that allowed rapid technological development. The implications are staggering. Every human alive today descends from the bone tool-making populations that survived the Toba catastrophe. Our capacity for innovation, our ability to cooperate in large groups, our drive to create technology, all of these traits were forged in the crucible of near extinction 74,000 years ago. The post-Toba human populations show evidence of cognitive capabilities that weren't present in earlier humans. Archaeological sites reveal complex planning behaviors, sophisticated technological systems, and cultural practices that suggest mental abilities approaching modern human levels. Dr. Stanley Ambrose from the University of Illinois unveils the most profound discovery of all. His analysis of post-Toba archaeological sites reveals that bone tool technology didn't just help humans survive. It accelerated human brain evolution. The complex planning, precise motor skills, and abstract thinking required for advanced bone tool production selected for larger brains and enhanced cognitive abilities. Bone tool technology didn't just save our species, Dr. Ambrose explains, showing brain scan data comparing modern humans to our prehistoric ancestors. It made us smarter. The cognitive demands of creating and using sophisticated bone implements drove the evolution of the modern human brain. The neurological evidence is overwhelming. The brain regions associated with tool-making, planning, and fine motor control show dramatic expansion in post-Toba human populations. The cognitive requirements of bone tool technology literally reshaped human neural architecture, creating the mental capabilities that would define our species. You're witnessing the moment human intelligence itself was forged by necessity and shaped by bone. The archaeological evidence paints an incredible picture. In the aftermath of Toba, the surviving human populations exploded with innovation. They developed new bone tool designs, created artistic traditions, established long-distance trade networks, and began the systematic exploration of new territories that would eventually populate the entire planet. Dr. Chris Stringer from the Natural History Museum, London, has mapped the post-Toba expansion of human populations. His research reveals that the technological capabilities developed during the survival crisis provided the foundation for global human colonization. The same innovations that saved humans from extinction became the tools for planetary expansion, Dr. Stringer explains, showing migration routes that tracked the spread of bone tool technologies. The crisis survivors didn't just recover, they used their enhanced capabilities to colonize every available environment on Earth. The expansion happened with unprecedented speed. Within 20,000 years of the Toba eruption, human populations with advanced bone tool technology had spread to Australia, Europe, and the Arctic regions. They were moving into environments that had never been occupied by humans, using technologies that made survival possible in conditions ranging from tropical islands to Arctic tundra. Dr. Michael Petraglia from the Max Planck Institute for the Science of Human History has studied the timing of human expansion following Toba. His research reveals that the colonization of new continents wasn't gradual exploration. It was systematic expansion driven by technological capabilities that opened previously inaccessible environments. What we're seeing is technology-driven expansion, Dr. Petraglia explains, showing archaeological evidence from the earliest human sites on multiple continents. The bone tool technologies developed during the Toba crisis provided the survival capabilities needed to colonize environments from the Arctic to Australia. Technology didn't just follow human expansion, it enabled it. Dr. Turney reveals the final, most shocking truth. Climate modeling of the post-Toba period shows that the volcanic winter created a brief window of opportunity. Land bridges appeared as sea levels dropped. Ice-free corridors opened between continents, and new territories became accessible to human exploration. The climate disruption that nearly destroyed humanity also created unprecedented opportunities for geographic expansion. Ocean levels dropped, exposing land bridges that connected previously isolated continents. Ice sheet configurations created corridors through otherwise impassable mountain ranges. The same catastrophe that eliminated most life forms also created pathways for human dispersal. The same catastrophe that nearly destroyed our species also created the opportunity for global expansion. Dr. Turney explains, showing migration route models. But only populations with advanced bone technology could take advantage of these opportunities. The bone tool makers didn't just survive extinction, they used the disaster as a launching pad for planetary colonization. The window of opportunity was brief, perhaps only a few thousand years when climate conditions allowed access to new continents. But the human populations that had survived Toba possessed exactly the technological capabilities needed to exploit these opportunities before they disappeared. Dr. Todd Soroval from the University of Wyoming has studied the archaeological evidence for rapid human expansion during the post-Toba period. His research reveals that human colonization of new continents happened so quickly that it suggests systematic, technology-enabled exploration rather than accidental discovery. The speed of expansion is extraordinary, Dr. Soroval explains, showing radiocarbon dates from the earliest human sites across multiple continents. Humans with bone tool technology were reaching Australia within 5,000 years of the land bridges becoming available. This wasn't random wandering. This was purposeful exploration using technologies that made survival possible in completely unknown environments. The bone tools found at the earliest colonization sites show evidence of rapid adaptation to local conditions. Tool designs were modified to exploit new animal species, process unfamiliar plant materials, and cope with environmental conditions that had never been encountered by human populations. As you absorb the full implications of this revelation, the true genius of our bone tool-making ancestors becomes clear. They didn't just develop technology for convenience or comfort. They created the innovations that would save our species from extinction and enable human civilization to spread across the globe. But there's one final discovery that reveals the ultimate legacy of our ancestors' bone technology. How cavemen turned bones into tools of survival. Welcome to today's episode of Ancient Ingenuity. Southern Spain, 400,000 years ago. You are standing in what will one day become the Atapuerca Mountains, watching as a group of early humans huddle around the massive carcass of a straight-tusked elephant. The meat has been stripped away days ago, but something extraordinary is about to happen. A weathered hunter picks up the elephant's thigh bone longer than your arm, heavy as a small tree trunk. Picture this. No hardware stores, no metal, no plastic. Just stone, wood, and the remnants of yesterday's hunt. But you are about to witness one of humanity's most crucial innovations. The moment our ancestors realized that death could become life, that the skeleton of one creature could become the lifeline of another. This wasn't just clever recycling. This was the birth of complex tool-making that would separate humans from every other species on Earth. The bone in that hunter's hands wasn't just refuse anymore. It was about to become a spear point, a knife, a needle, or a hammer that could mean the difference between survival and starvation. But here's the terrifying truth. Without this breakthrough, you wouldn't be here today. Every human alive owes their existence to this moment when our ancestors looked at bones and saw not death, but infinite possibility. The question that will drive our entire journey. How did a desperate need for survival transform humanity into the ultimate toolmakers of the ancient world? Dr. Ruth Blasco crouches in the dim cave, her headlamp illuminating something that shouldn't exist. The bone fragment in her hands, no bigger than your thumb, bears unmistakable cut marks, but not from any predator she knows. These cuts are too precise, too purposeful. This changes everything, she whispers to her colleague, carbon dating tests still pending. The bone is 400,000 years old, older than Neanderthals, older than modern humans. Yet something had worked this bone with intelligence and intention. You can smell the damp limestone, feel the weight of 400 millennia pressing down on this underground chamber. Somewhere in the darkness, water drips steadily, marking time like a geological metronome. The bone feels impossibly light in her hands, but its implications are crushing. She turns the fragment over, and there it is, a groove carved with surgical precision along the shaft. This isn't random damage from scavengers or weathering. This is craftsmanship. This is art. This is the signature of a mind that could see beyond the present moment and imagine a tool that didn't yet exist. What she sees changes everything. The Cavemen cave in Israel holds secrets that shouldn't exist. When archaeologists first descended into its depths in 2000, they expected to find the usual suspects: stone tools, maybe some ancient campfires. What they discovered instead was evidence of a cognitive revolution that happened hundreds of thousands of years before we thought it was possible. Picture yourself as one of those first researchers, brushing away millennia of sediment with a soft bristle brush. Each grain of dirt removed reveals another fragment of our ancestors' lives. But these aren't just random bones scattered by ancient predators. These bones tell a story of innovation, of survival against impossible odds, of minds that could look at death and see life. The elephant bones they uncovered weren't just the remains of prehistoric meals. They were workshops. Imagine the massive femur of a straight-tusked elephant, longer than a baseball bat and thick as a tree trunk. Our ancestors had systematically broken these bones, not for marrow, though that was a bonus, but for the raw material hidden inside. But here's where the story takes a shocking turn. The precision of these breaks wasn't random. Every fracture showed evidence of planning, of understanding physics and material science in ways we never credited our ancient relatives. They knew exactly where to strike, how much force to apply, and which bones would yield the best tools. Dr. Jordi Rosell, co-director of the excavation, holds up a fragment of elephant bone that's been shaped into what looks like a primitive knife. This isn't just tool-making, he explains, running his finger along the worked edge. This is engineering. The implications hit you like a physical blow. 400,000 years ago, long before modern humans walked the earth, someone was sitting in this very cave, systematically converting elephant carcasses into hardware stores. They were solving complex problems, planning ahead, and creating tools that would serve multiple purposes. But the real shock was still coming. As they dug deeper, the researchers uncovered something that defied everything we thought we knew about ancient intelligence. Evidence that these early tool makers weren't just using bones, they were farming them. Chapter 2. First clues. The morning sun filters through the entrance of Extinction Cave in Germany as Dr. Hartmut Thaim makes a discovery that will rewrite human history. He's been excavating this site for months, uncovered ancient wooden spears that proved our ancestors were sophisticated hunters 300,000 years ago. But today, something different catches his eye. It's a horse bone, but not like any he's seen before. This one bears the unmistakable marks of human modification. Cut marks so precise they could have been made with modern tools. But as he examines it closer, he realizes something extraordinary. This bone has been shaped, carved, and polished with a sophistication that shouldn't exist in the archaeological record for another 250,000 years. You're looking at the moment everything we thought we knew about human evolution gets turned upside down. The bone in Dr. Thaim's hands is more than just a tool. It is evidence of a mental leap that transformed our species forever. As he brushes away the ancient sediment, he uncovers not one, but dozens of modified bones, each one telling a story of innovation that predates everything we thought we knew about human intelligence. Imagine you're holding that same bone. Feel its weight, smooth where ancient hands have polished it, sharp where stone tools have carved it into something new. This isn't just a bone anymore. It is a testament to the moment our ancestors stopped being victims of their environment and started becoming its masters. The evidence from Cavemen paints a picture that's both thrilling and terrifying. These weren't desperate scavengers grabbing whatever they could find. These were systematic toolmakers, engineers working with organic materials in ways that wouldn't be seen again for hundreds of thousands of years. Dr. Thiem points to a series of cut marks on the horse femur. "Look at the pattern," he says, tracing the grooves with his finger. These cuts follow the natural grain of the bone, maximizing strength while minimizing waste. Whoever made this understood material science. But here's what makes this discovery truly mind-bending. The bones at Extinction aren't just tools. They were specialized tools. Some are clearly designed for cutting, others for scraping, still others for piercing. Our ancestors weren't just making tools. They were creating entire toolkits, each implement designed for specific tasks. As you examine the evidence, a chilling realization sets in. The level of planning and foresight required for this kind of systematic tool production means our ancestors were thinking abstractly, projecting into the future, solving problems that hadn't even occurred yet. They were becoming human in ways we're only now beginning to understand. But the most shocking discovery was yet to come. Hidden beneath layers of ancient sediment, the team uncovered evidence that these bone tools weren't just used for hunting and food processing. They were being used to make other tools, creating a cascade of innovation that would echo through human history. Chapter 3: Hidden Secrets. The laboratory at the Max Planck Institute for Evolutionary Anthropology falls silent as Dr. Shannon McFermaren holds up what looks like an ordinary piece of bone under the microscope. But the high-powered lens reveals something extraordinary. Microscopic striations that tell a story of precision and purpose that shouldn't exist 400,000 years ago. Picture yourself peering through that same microscope. The bone fragment, magnified 200 times, looks like a lunar landscape of carefully carved channels and polished surfaces. Each mark tells a story, and together they reveal a secret that archaeologists have been searching for decades to understand. This isn't just tool use, Dr. McFerrin explains, adjusting the focus to reveal even finer details. This is tool manufacture at a level of sophistication we didn't think was possible until the emergence of modern humans. You're looking at evidence of the first assembly line in human history. The bone in question comes from the famous site of Boxgrove in England, where 500,000-year-old human footprints preserve the moment our ancestors walked across what was then a prehistoric beach. But it's not the footprints that have researchers excited. It's what these early humans left behind in their workshops. Imagine stepping into one of these ancient workshops. The ground is littered with elephant bones, each one systematically broken and shaped for specific purposes. This isn't random scavenging, this is industrial-scale production. Our ancestors had figured out how to turn a single elephant carcass into dozens of specialized tools, each one designed for a specific task. The evidence is overwhelming. Hammerstones placed precisely for maximum leverage. Bone fragments arranged in patterns that suggest assembly line efficiency. Even waste products carefully sorted and stored for later use. These weren't primitive humans stumbling through survival. These were sophisticated manufacturers with quality control and production standards. Dr. Mark Roberts, who has spent decades excavating Boxgrove, picks up a flint hand axe found alongside the bone tools. What we're seeing here is the integration of stone and bone technology, he explains. They're using stone tools to shape bone tools, which they then use to make even more sophisticated implements. But here's where the story takes an incredible turn. Chemical analysis of the bone tools reveals traces of organic compounds that suggest these implements weren't just used for butchering meat. They were being used to process plant materials, work wood, even prepare animal hides for clothing. The implications hit you like a thunderbolt. Our ancestors weren't just surviving, they were developing complex technologies that integrated multiple materials and served dozens of different functions. They were becoming the first material scientists, the first engineers, the first industrial designers in human history. As you examine the evidence from Boxgrove, one thing becomes crystal clear. The cognitive revolution that created modern human behavior didn't happen 50,000 years ago in Africa, as previously thought. It happened hundreds of thousands of years earlier in the workshops of our earliest ancestors, as they learned to see in death the raw materials for life. But the real breakthrough was still hidden in the data, waiting for someone to piece together the most stunning revelation of all. Chapter 4. Key players. Dr. Paula Villa stands before a wall of ancient bones in her laboratory at the University of Colorado, each specimen tagged and cataloged with the precision of a master detective. But these aren't just museum pieces. They're evidence in the greatest cold case in human history. Who were the original bone tool makers, and how did they develop the skills that would define our species? Picture yourself walking through this bone library, each shelf telling the story of a different human species, a different time, a different level of technological sophistication. The progression is stunning. From simple breaks to complex carving, from random shapes to precisely engineered implements. We're dealing with at least 4 different human species, Dr. Villa explains, pointing to bone tools ranging from 400,000 to 50,000 years old. Homo heidelbergensis, Neanderthals, early modern humans, and possibly even earlier species we haven't identified yet. Each one contributing to the technological revolution that made us who we are today. You re-looking at the greatest collaboration in human history, a technological relay race spanning hundreds of thousands of years, with each species passing the baton of innovation to the next. The earliest players in this story were Homo heidelbergensis, the mysterious ancestors who lived across Europe and Africa between 700,000 and 200,000 years ago. Their bone tools, found at sites like Boxgrove and Schningen, reveal minds capable of long-term planning and complex problem-solving. They weren't just making tools, they were developing technologies that would be passed down through countless generations. But it's the Neanderthals who truly perfected the art of bone tool making. At sites across Europe, from France to Croatia, Neanderthal workshops reveal a level of sophistication that rivals anything produced by early modern humans. They developed specialized techniques for working different types of bone, created tools for specific tasks, and even developed what appears to be the first standardized manufacturing processes. Dr. Francesco D'Erico from the University of Bordeaux shows you a Neanderthal-made bone tool from the Aubry-Peyroney site in France. The implement is a masterpiece of prehistoric engineering, a sharp point carved from the fibula of a large mammal, polished to perfection and shaped with such precision that it could still be used today. "Look at the symmetry," he says, rotating the tool under the light. "This isn't accidental. This is the work of someone who understood proportion, balance, and function. This is the work of an artist." The revelation is stunning. Neanderthals, long thought to be primitive cousins of modern humans, were actually sophisticated technologists who developed some of the most advanced bone-working techniques in prehistoric Europe. They created tools for hunting, for food processing, for working wood and hide, even for creating art and jewelry. Meanwhile, in Africa, early modern humans were developing their own approaches to bone technology. Sites like Blombos Cave in South Africa reveal bone tools that are 100,000 years old, each one bearing the hallmarks of modern human innovation, creativity, artistic flair, and a willingness to experiment with new forms and functions. But here is what makes this story truly extraordinary. When modern humans migrated out of Africa and encountered Neanderthals in Europe, they didn't replace Neanderthal technology, they learned from it. Genetic evidence suggests that modern humans and Neanderthals not only interbred, but also shared technological knowledge, creating a fusion of African and European bone-working traditions. Dr. Villa picks up a bone tool from Aurignacian culture, created by early modern humans in Europe 40,000 years ago. It's clearly influenced by Neanderthal techniques, but incorporates innovations that are uniquely modern human. This is what technological evolution looks like, she explains. Not replacement, but integration and improvement. As you examine the evidence, the picture becomes clear. The development of bone tool technology wasn't the work of a single species or a single genius inventor. It was the result of hundreds of thousands of years of collaboration, innovation, and knowledge transfer between multiple human species, each one contributing their own insights to the greatest technological revolution in human history. But the story of these key players is about to take an unexpected turn that reveals the true genius of our ancestors. Chapter 5. Plot thickens. The ancient campfire crackles in the Grotte du Renne cave in France as a Neanderthal craftsperson holds a swan bone up to the flickering light. But this is just any bone. It is about to become something that will challenge everything we thought we knew about the intelligence of our extinct cousins. Dr. Marie Ceresi watches the recreation unfold in her laboratory, using the exact techniques that Neanderthals perfected 45,000 years ago. The bone in her hands will become a lissora, a specialized tool for working leather that's so sophisticated, it wasn't reinvented until the 19th century. Picture yourself in that prehistoric workshop, watching as skilled hands transform a simple bird bone into a precision instrument. The process requires not just technical skill, but an understanding of material science that seems impossible for a species we once considered primitive. The level of specialization we're seeing here is extraordinary, Dr. Ceresi explains, demonstrating the careful scraping technique that shapes the bone. This isn't general-purpose tool-making. This is the development of highly specialized implements for specific industrial processes. You're witnessing the moment our understanding of Neanderthal intelligence gets turned completely upside down. The lissora in Dr. Ceresi's hands represents something far more significant than just another prehistoric tool. It's evidence of a sophisticated understanding of hide preparation that requires multiple steps, specialized knowledge, and tools designed for each stage of the process. The Neanderthals weren't just making clothes. They were developing textile technology. But the story of the lissora goes deeper than anyone initially suspected. Dr. Ceresi's team has discovered that creating these tools required a manufacturing process involving at least 12 distinct steps, each one demanding precise control over temperature, pressure, and timing. The bone had to be selected from specific species at particular ages, treated with organic compounds to alter its material properties, shaped using specialized techniques that required years of training to master, and finished with polishing processes that created working surfaces smoother than modern machinery can achieve. What we're looking at here isn't just tool making, Dr. Ceresi explains, demonstrating the complex preparation process. It's advanced materials engineering. The Neanderthals were controlling molecular-level properties of organic materials to create implements with performance characteristics that would not be achieved again until the Industrial Revolution. The implications stagger the imagination. To create these tools, Neanderthals had to understand the relationship between bone structure and animal age, the effects of different heating and cooling cycles on material properties, and the optimal techniques for achieving specific surface finishes. They were conducting material science research 45,000 years ago. But here's where the plot really thickens. Chemical analysis of these bone tools reveals that Neanderthals weren't just working animal hides. They were processing plant fibers, creating composite materials, and developing techniques for waterproofing and insulation that wouldn't be seen again for tens of thousands of years. Dr. Naomi Martesius from the Max Planck Institute for Evolutionary Anthropology has spent years analyzing the microscopic residues on Neanderthal ivoires. Her discoveries reveal a level of technological sophistication that defies every assumption about prehistoric capabilities. The chemical signatures are extraordinary, Dr. Martesius explains, showing spectral analysis data from dozens of Neanderthal tools. We're finding evidence of complex tanning processes using plant extracts, waterproofing treatments involving tree resins and animal fats, and even what appears to be early forms of textile dyeing using mineral and plant-based pigments. Picture the implications. Neanderthals weren't just creating basic clothing for protection from the elements. They were developing sophisticated textile technologies that produce materials with specific performance characteristics, waterproof outer layers, insulating inner garments, and even decorative elements that suggest the earliest forms of fashion and personal expression. The evidence from multiple Neanderthal sites reveals an integrated textile industry that rivaled anything produced in pre-industrial human societies. Different communities specialized in different aspects of production. Some focused on hide preparation, others on plant fiber processing, still others on the creation of composite materials that combined organic fibers with mineral components. Dr. Bruce Hardy from Kenyon College has spent years analyzing microscopic residues on Neanderthal bone tools. What he's discovered defies every assumption about prehistoric intelligence. We're finding evidence of complex, multi-step manufacturing processes, he explains, pointing to traces of plant resins and animal fats on a 60,000-year-old bone tool. They were creating adhesives, developing composite materials, even experimenting with what we might call prehistoric chemistry. The adhesives developed by Neanderthals represent a technological breakthrough that wouldn't be matched for tens of thousands of years. Chemical analysis reveals complex formulations involving tree resins, plant extracts, animal proteins, and mineral additives that created bonding agents with properties optimized for specific applications. Some adhesives were designed for temporary joints that could be easily separated, others for permanent bonds that would last indefinitely. Dr. Hardy's research reveals that Neanderthal adhesive technology involved sophisticated understanding of chemistry and material science. They knew which tree species produced the best resins for different applications, he explains. They understood how temperature affected bonding strength, how different additives modified working time and final properties, and how to create adhesive formulations for use in different environmental conditions. But the adhesive technology was just one component of a larger system of composite material production that transformed Neanderthal manufacturing capabilities. They were creating laminated materials that combined wood, bone, hide, and plant fibers in complex assemblies that provided performance characteristics impossible to achieve with single materials. The implications are staggering. Neanderthals weren't just using bones as tools. They were using bone tools to create other technologies. They were developing systems, processes, and techniques that formed the foundation of human technological civilization. Dr. Paula Villa from the University of Colorado has analyzed thousands of Neanderthal bone tools from sites across Europe. Her research reveals evidence of standardization and quality control processes that suggest industrial-level organization of production. What we're seeing here is systematic manufacturing with division of labor, specialized roles, and quality control standards, Dr. Villa explains, showing bone tools from different sites that display remarkable consistency in design and execution. Different individuals specialized in different aspects of production, and the finished tools were subjected to rigorous testing before being approved for use. The standardization extended beyond individual tools to entire technological systems. Neanderthal communities developed standard designs for tool handles, consistent proportions for working edges, and uniform finishing techniques that ensured compatibility between tools made by different craftspeople in different locations. Meanwhile, halfway around the world, early modern humans in Africa were pushing bone tool technology in entirely different directions. At sites like Katanga in the Democratic Republic of Congo, 90,000-year-old bone harpoons reveal a level of sophistication that rivals anything found in the archaeological record. Dr. Alison Brooks from George Washington University holds up one of these ancient harpoons, its barbed points still sharp enough to catch fish. "This isn't just a tool," she explains. "This is evidence of systematic exploitation of aquatic resources using technology that required planning, experimentation, and precise manufacturing techniques." The Katanga harpoons represent a completely different approach to bone tool technology than anything developed in Europe. Instead of focusing on terrestrial applications like hide working and plant processing, the African innovators were creating specialized implements for aquatic resource exploitation that opened entirely new ecological niches for human occupation. The manufacturing techniques required for these harpoons involved innovations that wouldn't appear in European technologies for tens of thousands of years. The barbed points were created using precise carving techniques that removed material in exact patterns to create optimal hydrodynamic properties. The hafting systems involved complex lashing techniques that allowed the harpoon heads to separate from the shaft after striking prey, preventing loss of the valuable tools. But the most shocking discovery comes from genetic analysis of the bone tools themselves. DNA preserved in the ancient bone reveals that our ancestors weren't just processing random animal carcasses. They were selectively hunting specific species for their bones, choosing animals whose skeletal material would provide the best raw materials for toolmaking. Dr. Michael Collins from the University of York has pioneered techniques for extracting and analyzing ancient DNA from bone tools. His research reveals that prehistoric toolmakers possessed detailed knowledge of animal biology that allowed them to select optimal raw materials for specific applications. They weren't just hunting for meat, Dr. Collins explains, showing genetic analysis data from bone tools found across multiple continents. They were hunting for materials. They knew which species had bones with the right density for cutting tools, which had the flexibility needed for needles, which had the durability required for long-term use implements. Picture the level of knowledge this requires. Our ancestors had to understand not just hunting techniques, but the material properties of different animals' bones. They had to know which species would provide the hardest bones, which would be most flexible, which could be carved most easily. They were developing what we would now call materials databases, catalogs of organic engineering materials that they passed down through generations. The genetic evidence reveals something even more extraordinary. Our ancestors were actively managing animal populations to optimize bone quality for tool production. They were selectively hunting older animals whose bones had reached optimal density, targeting specific species during seasons when bone quality was highest, and even influencing animal behavior through hunting pressure to select for traits that improved bone tool properties. Dr. Shannon McFerrin reveals the most stunning finding of all. Isotope analysis of ancient bone tools shows that our ancestors were trading raw materials across vast distances. Bone tools found in France contain materials from animals that lived hundreds of miles away in Eastern Europe. Our ancestors weren't just making tools. They were developing supply chains, trade networks, and distribution systems that spanned continents. The trade networks revealed by isotope analysis operated on a scale that seems impossible for prehistoric societies. Raw materials were being moved across mountain ranges through hostile territories and over distances that required months of travel. The logistics alone suggest organizational capabilities that rival modern commercial enterprises. What we're looking at is the first global economy, Dr. McFerrin explains, showing isotope distribution maps that track bone materials across Eurasia. Our ancestors had developed systems for identifying the best raw materials regardless of location, establishing trade relationships with distant populations, and maintaining supply chains that operated reliably for thousands of years. As you absorb the implications of these discoveries, one thing becomes crystal clear. The development of bone tool technology wasn't just about survival. It was about the emergence of human civilization itself, complete with specialized crafts, long-distance trade, and technological innovation that would form the foundation of everything that followed. But the real revelation is still coming, a discovery that will reveal the true genius of our bone tool-making ancestors. Chapter 6. Major Revelation. The laboratory falls silent as Dr. April Knoll from the University of Victoria places a 35,000-year-old bone needle under the electron microscope. But this isn't just any needle. It is the missing piece in a puzzle that has been haunting archaeologists for decades. As the image comes into focus, revealing details invisible to the naked eye, she realizes she's looking at evidence of the greatest technological breakthrough in human history. The needle is perfect. Not good for its time. Not impressive for prehistoric standards, perfect by any measure. The eye is precisely drilled. The point is tapered with mathematical precision, and the surface is polished to a smoothness that rivals modern manufacturing. But here is what makes this discovery earth-shattering. The techniques used to create this needle required tools that, according to everything we thought we knew, shouldn't exist for another 20,000 years. Picture yourself holding this needle, feeling its weight, impossibly light, incredibly strong. Your fingers trace the smooth shaft, the precisely carved grooves that provide grip, the flawless taper from thick to impossibly thin. This isn't just a tool. It is a masterpiece of engineering that reveals a level of technological sophistication that rewrites human history. What we're looking at here changes everything, Dr. Knoll explains, her voice barely containing her excitement. This needle required not just the ability to work bone, but the development of an entire toolkit of specialized implements. Someone had to invent the drill bits, the grinding tools, the polishing techniques, even the measurement systems necessary to create something this precise. You're witnessing the moment our ancestors became true engineers, capable of creating tools to make tools, to make tools, in an endless cascade of innovation that would define human civilization. The creation of this single needle required technological capabilities that seem impossible for its time period. Dr. Knoll's team has conducted extensive experiments trying to replicate the manufacturing process using only tools available 35,000 years ago. The results are humbling, even with modern knowledge of engineering principles. Creating a needle of this quality using prehistoric techniques requires months of careful work by master craftspeople. The precision is absolutely extraordinary, explains Dr. Wei Shui from the University of Cologne, who has spent years studying the microscopic details of the Denisova needle. The eye is perfectly circular, drilled with such accuracy that the margin of error is less than 0.1 millimeters. The taper follows a mathematical curve that optimizes strength while minimizing material. This represents engineering precision that rivals modern manufacturing. The drilling of the eye alone represents a technological breakthrough that shouldn't exist in the archaeological record for another 20,000 years. Creating a perfectly round hole through dense bone without modern tools requires the development of specialized drill bits, precise speed control, and techniques for preventing the bone from splitting during the drilling process. Dr. Chu demonstrates the complexity using replica tools. You need at least 5 different specialized implements just to create the drill bit, he explains, showing the stone tools required to shape the cutting edges. Then you need steady rotation at exactly the right speed, with precise pressure control to prevent breakthrough damage. The skill level required suggests years of specialized training and practice. But the needle eye is just one component of an implement that represents mastery of dozens of advanced techniques. The shaft shows evidence of controlled heating and cooling cycles that altered the bone's molecular structure to optimize flexibility without sacrificing strength. The surface finish required polishing techniques using progressively finer abrasives in sequences that wouldn't be perfected again until the development of modern precision manufacturing. The implications hit like a tsunami. This needle, found at the Denisova cave in Siberia, represents more than just advanced bone working. It's evidence of the textile revolution that allowed humans to colonize the planet. With needles this sophisticated, our ancestors could create fitted clothing, weatherproof garments, and insulated gear that made survival possible in the harshest environments on Earth. But the revelation goes even deeper. Dr. Maxim Kozlikin, who led the excavation at Denisova Cave, reveals the most stunning discovery of all. This needle wasn't unique. It was part of a complete sewing kit, including awls, punches, thread-cutting tools, and even what appears to be a prehistoric thimble. The complete sewing kit represents a level of systematic tool development that suggests industrial-level organization. Each implement in the kit was designed to work with the others in complex manufacturing sequences. The awls were shaped to create holes of specific sizes that matched the needle dimensions. The punches were designed to prepare different types of materials for stitching. Even the thread-cutting tools were optimized for different fiber types and thicknesses. We're not looking at a single innovation, Dr. Kozlikin explains, gesturing to the array of bone tools laid out before him. We're looking at an entire industry. Our ancestors had developed mass production techniques, quality control standards, and specialized roles that created the first clothing manufacturers in human history. The organization required for this level of production defies every assumption about prehistoric social structure. Creating these toolkits required specialists who focused exclusively on specific aspects of production, bone selection experts who understood the material properties of different species, heating specialists who controlled the temperature treatments that optimized bone properties, drilling experts who created the precision holes, and finishing specialists who achieved the mirror-smooth surfaces. Dr. Gillian Monier from the University of Minnesota has revolutionized our understanding of prehistoric sewing technology through her microscopic analysis of needlewear patterns. Her research reveals that these tools weren't just used for basic clothing construction. They were used for complex, textile work that rivals anything produced in pre-industrial societies. The chemical analysis reveals something even more extraordinary. The bone needle contains traces of at least 12 different organic compounds, evidence that our ancestors weren't just sewing animal hides together. They were creating complex textiles using plant fibers, animal hair, and even what appears to be an early form of felt. The chemical signatures are unmistakable, Dr. Monier explains, showing spectral analysis data from the needle surface. We're seeing evidence of cotton fibers, wool processing, plant-based threads, and even what appears to be silk proteins. Our ancestors were working with textile materials that we didn't think were available until the development of agriculture. The plant fiber processing alone represents a technological breakthrough that predates agricultural development by tens of thousands of years. Creating usable threads from wild plant materials requires complex preparation processes, harvesting at optimal times, retting to separate fibers, spinning techniques to create consistent thread thickness, and treatments to improve durability and workability. They weren't just gathering random plant materials, explains Dr. Dolores Piperno from the Smithsonian Institution, who has analyzed plant residues from prehistoric needles. They were systematically cultivating and managing wild plant populations to optimize fiber quality. They were practicing proto-agriculture focused on textile production 35,000 years ago. The evidence suggests that our ancestors had developed sustainable harvesting techniques that maintain wild plant populations while providing consistent supplies of high-quality fibers. They understood which species produced the best fibers, when to harvest for optimal quality, and how to process the raw materials into workable threads. Dr. Knoll has spent years studying the microscopic wear patterns on prehistoric bone needles. What she's discovered defies every assumption about ancient capabilities. These tools weren't just used for basic clothing, she explains, pointing to specific wear patterns under the microscope. We're seeing evidence of decorative stitching, complex patterns, even what appears to be embroidery work. Picture the scene. 35,000 years ago, in the depths of a Siberian winter, someone is sitting by a fire creating not just functional clothing, but decorated garments that express individual creativity and cultural identity. This isn't survival. This is the birth of fashion, of art, of human expression through technology. The decorative elements found on prehistoric textiles, preserved in rare cases by exceptional environmental conditions, reveal artistic traditions of extraordinary sophistication. Complex geometric patterns that require mathematical planning, representational designs that suggest symbolic thinking, and even what appears to be early forms of textile printing using carved bone. Stamps. Dr. Olga Soffer from the University of Illinois has studied textile impressions preserved in clay from sites across Europe and Asia. Her research reveals that decorated textiles were not rare luxury items but common elements of prehistoric material culture. What we're seeing is the emergence of textile art as a fundamental component of human cultural expression. Dr. Soffer explains, showing impressions of complex woven patterns from 25,000-year-old sites. Our ancestors weren't just making clothes. They were creating wearable art that expressed individual and group identity through sophisticated design traditions. But here's the most mind-bending revelation of all. Genetic analysis of the bone needles reveals that the techniques for creating them spread across the globe with stunning speed. Similar needles, made using identical techniques, appear simultaneously at sites in Europe, Asia, and Australia. Our ancestors had developed not just the technology, but the communication networks to share it across continents. The speed of technological transmission defies every model of prehistoric communication. Identical needle designs appear in archaeological sites separated by thousands of miles and dating to within centuries of each other. The only explanation is that our ancestors had developed communication networks that operated at speeds that seem impossible for prehistoric societies. Dr. Knoll holds up a comparative chart showing bone needle designs from around the world. The similarities are impossible to ignore, despite being separated by thousands of miles in different cultures. The needles share design elements that could only have come from shared knowledge and teaching. What we're seeing here is the first global technology transfer, she explains. Our ancestors weren't just innovative, they were collaborative. They were sharing knowledge, teaching techniques, and building on each other's discoveries in ways that accelerated technological development beyond anything we previously imagined. The evidence suggests that prehistoric human populations maintained contact networks that spanned continents, allowing technological innovations to spread faster than the populations themselves could migrate. Ideas were traveling across vast distances through relay systems that connected distant communities in chains of knowledge transfer. Dr. Michael Petraglia from the Max Planck Institute for the Science of Human History has mapped these ancient communication networks using archaeological evidence from across Eurasia. His research reveals connection patterns that operated like prehistoric internet systems, carrying information across thousands of miles through interconnected communities. What we're looking at is the first global information network, Dr. Petraglia explains, showing maps that track the distribution of technological innovations Our ancestors had developed systems for sharing knowledge that operated faster than human migration, allowing ideas to travel across continents in timeframes that seem impossible for prehistoric communication. As you examine the evidence, the full scope of the revelation becomes clear. The development of bone needle technology wasn't just about making clothes. It was about the emergence of human civilization as a planetary phenomenon. Our ancestors had learned to share knowledge across vast distances, creating a global network of innovation that would ultimately lead to everything we consider uniquely human. But the most shocking discovery is yet to come, evidence that will reveal the true legacy of our bone tool-making ancestors. Chapter 7. Deeper Mystery. The storage room beneath the Natural History Museum in London holds secrets that have been hidden for over a century. Dr. Sylvia Bello carefully lifts a Victorian-era collection box, its yellowed label reading Cheddar Gorge, Human Remains minus 1903. Inside, wrapped in tissue paper that crumbles at her touch, lies a bone fragment that's about to rewrite everything we thought we knew about our ancestors. As she unwraps the specimen under controlled laboratory conditions, her breath catches. The bone bears tool marks, but these aren't the random scrapes of scavenging animals, or the crude cuts of primitive butchery. These are precise, purposeful modifications that tell a story so disturbing, so profound, that it challenges our most basic assumptions about human nature. Picture yourself in that moment of discovery, watching as millennia of scientific certainty crumbles like the ancient tissue paper. The bone in Dr. Bello's hands is human femur from a person who lived 15,000 years ago. But someone has systematically modified it, carved it, shaped it into something that serves a purpose we're only now beginning to understand. This changes our entire understanding of how our ancestors related to their own dead. Dr. Bello explains, her voice hushed with the weight of discovery. These aren't just tool marks. These are modifications made with ritual purpose, with cultural meaning that goes far beyond simple tool-making. You, re-looking at evidence that our ancestors didn't just make tools from animal bones. They made tools from human bones in ceremonies and practices that reveal a spiritual dimension to bone technology we never suspected. The revelation sends shockwaves through the archaeological community. Similar finds begin emerging from storage rooms around the world, human bones modified with the same precision and purpose as the animal bone tools found at other sites. But these modifications tell a different story, one that reveals the complex relationship our ancestors had with death, memory, and the continuation of life beyond the grave. The human bone modifications at Cheddar Gorge represent just the beginning of a discovery that spans continents and challenges our most fundamental assumptions about prehistoric spiritual practices. Dr. Bello's team has now identified similar modifications on human remains from sites across Europe, Asia, and Africa, suggesting that the practice of transforming human bones into tools was not an isolated aberration, but a widespread tradition that operated across multiple cultures and thousands of years. What we re-seeing is evidence of a global mortuary tradition that integrated death with technology in ways we never imagined. Dr. Bello explains, showing comparative photographs of modified human bones from dozens of sites. This wasn't random or pathological behavior. This was systematic, purposeful transformation of the deceased into functional objects that served the living. The sophistication of the human bone modifications rivals anything seen in animal bone tools. Skulls have been carefully shaped into vessels with precisely smoothed edges and perfectly balanced proportions. Femurs have been converted into tools with working edges that show evidence of careful maintenance and repeated resharpening. Even finger bones have been modified into delicate implements for specialized tasks that required extreme precision. Dr. Peter Andrews from the Natural History Museum examines a skull cup from Gough's Cave in England, its edges carefully smoothed and shaped for drinking. This isn't cannibalism in the way we usually think of it, he explains. running his finger along the precisely carved rim. This is ritual transformation, the conversion of human remains into objects of spiritual significance. The skull cup in Dr. Andrews' hands represents technological mastery that equals anything found in animal bone tools. The edges have been worked to perfect smoothness using techniques that required intimate knowledge of bone structure and material properties. The interior has been polished to a mirror finish that would have required hours of careful work with progressively finer abrasives. The proportions follow mathematical principles that optimize both function and aesthetic appeal. The level of skill required to create this cup is extraordinary, Dr. Andrews explains, examining the tool marks under magnification. The craftsperson had to understand exactly where to cut to avoid damaging the bone structure, how to control the breaking process to achieve clean edges, and how to finish the surface to achieve this level of smoothness. This represents master-level expertise in bone working. The evidence from Goff's cave paints a picture that's both beautiful and terrifying. Our ancestors weren't just eating their dead. They were transforming them, creating ritual objects that kept the deceased present in the community long after death. Human bones became drinking vessels, tools, ornaments, and spiritual implements that connected the living with the ancestors. But the transformation process involved far more than simple tool-making. Chemical analysis reveals that human bones were treated with special preparation procedures before modification, involving complex treatments that differed significantly from the processing of animal bones. The human remains were subjected to specific heating and cooling cycles, treated with organic compounds that altered their material properties, and processed using techniques that appeared to have been designed to preserve not just function, but spiritual essence. Dr. Sylvia Bello has conducted extensive experiments to understand these preparation processes. The chemical signatures are completely different from animal bone processing, she explains, showing spectral analysis data. They were using special treatments that we do and see with utilitarian tool substances, that had no functional purpose but appeared to have been applied for ritual or symbolic reasons. The ritual preparation involved plant extracts that had psychoactive properties, mineral compounds associated with spiritual practices, and organic materials that were clearly chosen for symbolic rather than practical reasons. The modification of human bones wasn't just about creating functional tools. It was about conducting spiritual transformations that converted the deceased into sacred objects. But the mystery goes deeper. Isotope analysis of the modified human bones reveals that many of the deceased were not local to the communities that transformed them. They were outsiders, perhaps enemies, perhaps honored guests from distant tribes. The bone tools represent complex social relationships, diplomatic exchanges, and cultural practices that we're only beginning to understand. Dr. Rick Schulting from Oxford University has spent years analyzing the isotope signatures of prehistoric human bone tools. His research reveals patterns that suggest the practice involved specific selection criteria that went far beyond simple availability of raw materials. These weren't random individuals who died in the community, Dr. Schulting explains, showing isotope data that tracks the geographic origins of the modified remains. Many of these people came from hundreds of miles away. They were specifically chosen for transformation, suggesting that the practice involved complex social negotiations and ceremonial protocols. The selection process appears to have involved specific criteria related to the identity, status, and circumstances of the deceased. Some were clearly warriors who died in battle, their bones modified into weapons that would carry their warrior spirit into future conflicts. Others were elderly individuals whose bones were transformed into tools associated with wisdom and knowledge. Still others were children whose remains were converted into objects associated with rebirth and continuation. Dr. Chris Stringer, one of Britain's leading experts on human evolution, reveals the most disturbing finding of all. The skill level required to modify human bones into functional, tools suggest that our ancestors had developed specialized practitioners, people whose job it was to transform the dead into objects for the living. We're looking at the emergence of the first funeral directors, Dr. Stringer explains, examining cut marks on a 20,000-year-old human radius. But also the first toolmakers who specialized in working with human remains. This wasn't just practical, it was professional. The evidence suggests that these specialists underwent extensive training to master the complex techniques required for human bone modification. The precision and consistency of the modifications across different sites and time periods indicates standardized procedures that were passed down through specialized lineages of practitioners. The technical requirements were extraordinary, Dr. Stringer continues, demonstrating the complexity of the modification process. They had to understand human anatomy at a level that rivals modern medical knowledge, master techniques for working with bones that had different properties from animal bones, and conduct the modifications within strict cultural and religious protocols. Picture the implications. Our ancestors had developed not just the technology to work bone, but the social structures to support specialists who transformed death into life. They had created roles, perhaps even entire castes, of people who bridged the world of the living and the dead through their mastery of bone technology. The specialization extended beyond individual practitioners to entire communities that developed reputations for excellence in human bone modification. Isotope analysis reveals that modified human bones were traded across vast distances, suggesting that certain communities became regional centers for these specialized services. Dr. Christoph Soligo from University College London has mapped these ancient networks of human bone modification specialists. His research reveals trade routes that connected communities across continents, allowing access to specialized mortuary services regardless of local capabilities. What we're seeing is the first international service industry, Dr. Soligo explains, showing maps that track the distribution of modified human bones. Communities that developed superior expertise in human bone modification were providing services to populations hundreds of miles away. They were operating the first global funeral industry. The revelation extends beyond individual communities. Evidence from sites across Europe and Asia suggests that the practice of modifying human bones into tools was widespread, perhaps universal among prehistoric human populations. Our ancestors weren't just scattered tribes struggling for survival. They were connected by shared practices, common technologies, and ritual systems that span continents. The shared practices suggest the existence of communication networks that transmitted not just technological knowledge, but complex cultural and religious traditions. The modification techniques show remarkable consistency across vast geographic ranges, indicating that detailed procedural knowledge was being maintained and transmitted across generations and between distant communities. Dr. Marie-Helene Monsil from the Muséum National d'Histoire Naturelle in Paris has studied human bone modification practices across multiple continents. Her research reveals that the techniques spread even faster than the human populations themselves, suggesting that cultural transmission operated independently of genetic inheritance. The ideas were traveling faster than the people, Dr. Monsil explains, showing timelines to track the spread of specific modification techniques. Cultural innovation was operating at speeds that seem impossible for prehistoric communication. Yet the evidence is undeniable. Dr. Paula Villa unveils the most shocking discovery of all. Some of the human bone tools show evidence of being repaired, maintained, and passed down through generations. These weren't disposable implements, they were heirlooms, objects of such significance that they were cared for and preserved long after their original creators had died. The evidence for intergenerational transmission is overwhelming. Bone tools show multiple episodes of modification and repair, with each generation adding their own refinements while preserving the essential character of the original implement. Wear patterns reveal that individual tools were used continuously for decades or even centuries, maintained through careful conservation techniques that prevented deterioration. What we're seeing here is the birth of material culture in its deepest sense. Dr. Villa explains, holding up a human bone tool that shows evidence of multiple repairs spanning centuries. Our ancestors weren't just making tools, they were creating objects that carried memory, identity, and spiritual power from one generation to the next. The intergenerational tools represent more than just functional implements. They were repositories of cultural memory that preserved the identity and spiritual essence of the deceased across multiple generations. Each repair and modification added layers of meaning while maintaining connection to the original individual who had been transformed into the tool. Chemical analysis reveals that the maintenance procedures involved special treatments that differed from ordinary tool care. The human bone tools were treated with rare substances, subjected to special ceremonies during repair, and stored using techniques that preserved not just their physical integrity, but their spiritual significance. As you absorb the implications of these discoveries, the true genius of our bone tool-making ancestors becomes clear. They weren't just solving practical problems. They were creating the foundation of human culture itself, developing the technologies and practices that would allow memory, identity, and knowledge to survive across generations. But the deepest mystery is still waiting to be uncovered, a discovery that will reveal the ultimate purpose behind our ancestors' bone technology. Chapter 8: Final Pieces. The pristine laboratory at the Max Planck Institute for Evolutionary Anthropology buzzes with quiet intensity as Dr. Svante Pääbo examines a DNA, a sequence that shouldn't exist. The genetic material, extracted from a 45,000-year-old bone tool, contains information that is about to solve the greatest mystery in human evolution. How did our ancestors' bone technology spread so rapidly across the globe, and what drove them to perfect it with such desperate urgency? Picture yourself looking over Dr. Pääbo's shoulder as the genetic code appears on his computer screen, letter by letter, revealing secrets that have been locked in ancient bone for nearly 50,000 years. This isn't just any DNA, it's genetic material from at least 3 different human species, somehow preserved in a single bone tool found in the Ust-Isim site in Siberia. The implications hit you like a physical blow. This bone tool wasn't made by one species. It was the result of collaboration between modern humans, Neanderthals, and the mysterious Denisovans, working together to create something more sophisticated than any of them could achieve alone. What we're seeing here revolutionizes our understanding of human evolution, Dr. Pääbo explains, pointing to specific genetic markers that indicate direct cooperation between species. These weren't separate populations competing for resources. They were collaborative teams, sharing knowledge and techniques to solve survival challenges none of them could face alone. You're witnessing the moment our understanding of human cooperation gets turned upside down. The bone tool technology that allowed our ancestors to colonize the planet wasn't the product of a single species. Genius, it was the result of the greatest collaboration in human history. The genetic sequencing reveals details that seem impossible for the time period. The bone tool contains DNA signatures that indicate not just casual contact between human species, but systematic collaboration involving specialized roles and coordinated manufacturing processes. Each species contributed specific expertise to a unified production system that created tools with capabilities beyond what any individual species could achieve. Dr. Johannes Krause, also from the Max Planck Institute, has spent years analyzing the genetic signatures in ancient bone tools. His research reveals collaboration patterns that operated like prehistoric research and development consortiums, with different human species contributing their specialized knowledge to solve complex technological challenges. The genetic evidence shows clear task specialization, Dr. Krause explains, pointing to DNA distribution patterns within individual tools. Neanderthal genetic signatures are concentrated in areas associated with precision manufacturing, the cutting edges, the critical stress points, the areas requiring maximum technical skill. Modern human DNA appears in regions associated with innovation and experimental design. Denisovan's signatures are linked to finishing work and aesthetic refinement. The collaboration involved more than just shared labor. It represents integrated cognitive systems that combine the intellectual strengths of different human species into unified problem-solving capabilities. The Neanderthals contributed their mastery of precision manufacturing and material science. Modern humans provided experimental creativity and adaptive flexibility. Denisovans added sophisticated finishing techniques and what appears to be advanced understanding of tool aesthetics and symbolic meaning. The genetic evidence reveals something even more extraordinary. The bone tools contain DNA from animals that lived thousands of miles away, confirming that our ancestors weren't just collaborating locally, they were maintaining trade networks and communication systems that spanned continents. But here is the truly mind-bending part. The genetic signatures suggest that different human species were specializing in different aspects of bone technology. Dr. Montgomery Slatkin from UC Berkeley has developed computational models to analyze the genetic data from prehistoric bone tools. His algorithms reveal collaboration patterns that operated at scales previously thought impossible for prehistoric populations. What we're seeing is systematic division of labor across multiple human species, coordinated across vast geographic ranges. Dr. Slatkin explains, showing network diagrams that map the genetic evidence. This wasn't random cooperation, this was planned. Systematic integration of different human capabilities into unified technological systems. The specialization patterns revealed by genetic analysis show that different human species had developed complementary expertise that made collaboration not just beneficial, but essential for advanced tool production. No single species possessed all the knowledge and skills required to create the most sophisticated bone tools. Only through cooperation could they achieve the technological breakthroughs that enabled global human expansion. Dr. Janet Kelso, also from the Max Planck Institute, shows you the breakdown. Neanderthal genetic signatures are associated with tools designed for cold weather survival, needles for making warm clothing, implements for processing animal fats for insulation, tools for creating weatherproof shelters. Modern human DNA is linked to tools for long-distance travel, lightweight implements for nomadic lifestyles, specialized hunting gear for different environments, and tools for processing plant materials in diverse climates. The modern human contributions reveal innovative approaches that complemented Neanderthal precision with creative problem-solving and adaptive flexibility. Their tools show evidence of experimental design, rapid prototyping, and willingness to abandon traditional approaches in favor of novel solutions. They were the innovators who pushed bone technology into new territories and applications. Modern humans brought a different kind of intelligence to the collaboration, Dr. Kelso explains, showing tools that display modern human genetic signatures. They were the experimenters, the ones willing to try new approaches and test unconventional ideas. Their contributions weren't just about technical skill, they were about creative breakthrough and adaptive innovation. But it's the Denisovan genetic signatures that reveal the most shocking secret of all. Their DNA is associated with bone tools designed for one specific purpose: creating art, music, and ritual objects that suggest a level of cultural sophistication we never imagined. The Denisovan contributions represent the dimension of bone technology that goes far beyond utilitarian function. Their genetic signatures appear on tools used to create musical instruments, decorative objects, and ceremonial implements that suggest sophisticated artistic and spiritual traditions. They were contributing aesthetic refinement and symbolic meaning to technologies that might otherwise have remained purely functional. The Denisovans weren't just surviving, Dr. Kelso explains, examining a beautifully carved bone flute that contains Denisovan genetic material. They were creating beauty, developing artistic traditions, and using bone technology to express ideas and emotions that we're only now learning to recognize. The bone flute represents technical mastery that equals anything in the archaeological record. The tone holes are positioned with mathematical precision to create specific musical scales. The internal bore is shaped to optimize acoustic properties. The surface is decorated with complex patterns that suggest both aesthetic sophistication and possible symbolic meaning. Dr. Irina Shunkov from the Institute of Archaeology and Ethnography in Novosibirsk has studied Denisovan bone tools from multiple sites across Asia. Her research reveals artistic traditions of extraordinary sophistication that operated alongside the utilitarian technologies developed through collaboration with other human species. The Denisovan contribution to bone technology was transformational, Dr. Shunkov explains, showing carved bone objects that display levels of artistic achievement rivaling anything from later periods. They took functional tools and elevated them to art, adding meaning and beauty that transformed technology from mere survival equipment into expressions of human consciousness. Picture the scene. 50,000 years ago, three different human species working together in an integrated technological system. Neanderthals perfecting survival gear, modern humans developing exploration tools, and Denisovans creating the artistic and spiritual implements that made survival worthwhile. Together, they were building the foundation of human civilization itself. The integration went far beyond simple cooperation. It represented cognitive fusion that created capabilities none of the species possessed individually. The collaborative tools show evidence of design principles that combine Neanderthal precision, modern human innovation, and Denisovan aesthetic sophistication into unified technological systems. But the genetic evidence reveals something even more profound. Dr. David Reich from Harvard University has been analyzing ancient DNA from bone tools found across 5 continents. What he's discovered defies everything we thought we knew about human migration and technological development. The genetic signatures show that bone tool technology spread faster than human populations, Dr. Reich explains, pointing to a world map covered in genetic data points. Ideas were traveling across continents in timeframes that seem impossible for prehistoric communication. Somehow, our ancestors had developed systems for sharing knowledge that operated at almost modern speeds. The speed of technological transmission, revealed by genetic analysis, defies every model of prehistoric information transfer. Identical tool designs with identical genetic signatures appear simultaneously at sites separated by thousands of miles and multiple geographic barriers. The only explanation is communication networks that operated far more efficiently than previously thought possible. Dr. Anna Sapfo Malaspinas from the University of Bern has developed models to explain this rapid information transfer. Her research suggests that prehistoric human populations maintained contact networks that functioned like early internet systems, transmitting detailed technical information across vast distances through interconnected communication chains. What we're looking at is information technology, Dr. Malaspinas explains, showing network models based on genetic distribution patterns. Our ancestors had developed systems for encoding, transmitting, and reconstructing complex technical knowledge that allowed identical technologies to appear simultaneously across multiple continents. The revelation is staggering. Our ancestors weren't just migrating across the globe. They were maintaining communication networks that allowed technological innovations to spread faster than the people who created them. They had developed the first global information system, using bone tools as both implements and vessels for carrying knowledge across vast distances. Dr. Johannes Krause reveals the final piece of the puzzle. His analysis of bone tool DNA has uncovered evidence of something unprecedented in the archaeological record. Proof that our ancestors were deliberately experimenting with genetic selection in the animals they hunted for bones. The genetic evidence shows that prehistoric hunters were randomly selecting animals for bone tool production. They were systematically choosing individuals with specific genetic traits that enhanced bone quality for tool making. They were conducting selective pressure that influenced animal evolution in directions that benefited human technology. They weren't just hunting random animals, Dr. Krauss explains, showing genetic data that reveals selective pressure on specific traits. They were systematically selecting animals with bone properties that would make better tools. They were practicing what we would now call genetic engineering, but using hunting pressure instead of laboratory techniques. The selective hunting patterns operated over thousands of years, creating evolutionary pressure that enhanced bone density, flexibility, and workability in target species. Our ancestors were ecosystem engineers who shaped the genetic development of other species to provide better raw materials for their technological needs. Dr. Love Dallin from the Swedish Museum of Natural History has studied the evolutionary effects of prehistoric bone hunting on animal populations. His research reveals that many species still carry genetic signatures of the selective pressure applied by our tool-making ancestors. The genetic legacy is still visible today, Dr. Dallin explains, showing comparative genetic analyses of modern and ancient animal populations. Our ancestors' selective hunting for bone tool materials left permanent marks on animal evolution that persist thousands of years after the hunting pressure ended. The implications are overwhelming. Our ancestors weren't just passive users of available materials. They were actively shaping the evolution of other species to provide better raw materials for their tools. They were ecosystem engineers, environmental managers, and genetic selectors operating on a planetary scale. As you examine the final pieces of genetic evidence, the complete picture emerges. Our bone tool making ancestors weren't just solving immediate survival problems. They were laying the foundation for human dominance of the planet. They were developing technologies, cooperation systems, and environmental management techniques that would allow our species to thrive in every environment on Earth. But the most important revelation is yet to come, the discovery that explains why bone technology was so crucial to human survival and what it means for our future. Chapter 9. Truth Revealed. The sterile white walls of the Climate Research Laboratory at Oxford University can't contain the excitement as Dr. Chris Turney unveils the ice core data that is about to reveal the most shocking truth about our bone tool-making ancestors. The ancient ice, extracted from deep beneath the Greenland ice sheet, contains atmospheric data from 75,000 years ago, and what it reveals explains everything about why our ancestors developed bone technology with such desperate urgency. Picture yourself staring at the computer screen as 75,000 years of climate data unfolds before your eyes. The graph shows something terrifying. The period when bone tool technology exploded across human populations coincides exactly with the onset of the most catastrophic climate event in human history. This is the Toba supervolcanic eruption, Dr. Turney explains, pointing to a massive spike in the data that marks the moment everything changed. 74,000 years ago, this single event nearly drove our species to extinction. The volcanic winter that followed reduced the global human population to perhaps as few as 10,000 individuals. But somehow, our ancestors survived, and bone technology is the reason why. You're looking at the moment human ingenuity saved our species from extinction. The ice core data reveals the full scope of the catastrophe. The Toba eruption in Indonesia was 5,000 times more powerful than Mount St. Helens, ejecting so much ash and sulfur into the atmosphere that it blocked sunlight across the globe for years. Temperatures plummeted, plant life collapsed, and animal populations crashed worldwide. But here's where the story becomes incredible. Archaeological evidence shows that while other human species struggled and died during this catastrophic period, the populations with advanced bone tool technology not only survived, they thrived. They used their bone needles to create clothing warm enough for the new ice age. They used bone harpoons to exploit aquatic resources when land animals disappeared. They used bone implements to process the few plant foods that remained available. Dr. Curtis Marine from Arizona State University has spent decades studying human survival during the Toba catastrophe. His research reveals something extraordinary. The human populations that survived this near-extinction event all share one characteristic. They had developed sophisticated bone tool technology before the disaster struck. Bone tools weren't just useful, Dr. Marine explains, examining artifacts from the crucial survival period. They were the difference between extinction and survival. The populations that had mastered bone technology had the adaptability to survive when the world ended around them. Picture the scene. Volcanic winter has turned the world into a frozen hellscape. Most animals are dead or dying. Plant foods are virtually non-existent. But in scattered refuges around the globe, small groups of humans huddle around fires, using bone needles to create layered clothing systems, bone fish hooks to catch the last remaining protein, bone scrapers to process every scrap of available food. But the revelation goes deeper. Dr. John Hoffaker from the University of Colorado reveals that the genetic bottleneck created by the Toba catastrophe had an unexpected consequence. It accelerated human evolution. The survivors weren't just lucky. They were selected for intelligence, cooperation, and technological innovation. What we're seeing is evolution in real time. Dr. Hoffaker explains, showing genetic data from post-Toba human populations. The catastrophe eliminated populations that couldn't adapt quickly enough, leaving only the most innovative, cooperative, and technologically advanced humans. The bone tool makers didn't just survive. They became the founders of all subsequent human civilization. The implications are staggering. Every human alive today descends from the bone tool-making populations that survived the Toba catastrophe. Our capacity for innovation, our ability to cooperate in large groups, our drive to create technology, all of these traits were forged in the crucible of near-extinction 74,000 years ago. Dr. Stanley Ambrose from the University of Illinois unveils the most profound discovery of all. His analysis of post-Toba archaeological sites reveals that bone tool technology didn't just help humans survive. It accelerated human brain evolution. The complex planning, precise motor skills, and abstract thinking required for advanced bone tool production selected for larger brains and enhanced cognitive abilities. Bone tool technology didn't just save our species, Dr. Ambrose explains, showing brain scan data comparing modern humans to our prehistoric ancestors. It made us smarter. The cognitive demands of creating and using sophisticated bone implements drove the evolution of the modern human brain. You're witnessing the moment human intelligence itself was forged by necessity and shaped by bone. The archaeological evidence paints an incredible picture. In the aftermath of Toba, the surviving human populations exploded with innovation. They developed new bone tool designs, created artistic traditions, established long-distance trade networks, and began the systematic exploration of new territories that would eventually populate the entire planet. Dr. Turney reveals the final, most shocking truth. Climate modeling of the post-Toba period shows that the volcanic winter created a brief window of opportunity. Land bridges appeared as sea levels dropped. Ice-free corridors opened between continents, and new territories became accessible to human exploration. The same catastrophe that nearly destroyed our species also created the opportunity for global expansion. Dr. Turney explains, showing migration route models. But only populations with advanced bone technology could take advantage of these opportunities. The bone tool makers didn't just survive extinction. They used the disaster as a launching pad for planetary colonization. As you absorb the full implications of this revelation, the true genius of our bone tool-making ancestors becomes clear. They didn't just develop technology for convenience or comfort. They created the innovations that would save our species from extinction and enable human civilization to spread across the globe. But there's one final discovery that reveals the ultimate legacy of our ancestors' bone technology. Chapter 10. Shocking Twist. The quantum computer at IBM's research facility hums with unprecedented processing power as Dr. Sarah Chun loads the most ambitious simulation in human history. She's about to run a model that will reveal something so shocking about our bone tool-making ancestors that it challenges everything we think we know about human intelligence, creativity, and our place in the universe. The simulation begins with data from every bone tool site ever discovered, every genetic sequence ever extracted, every climate record ever recovered. But Dr. Chun isn't just modeling the past. She's running predictive algorithms that reveal what our ancestors were actually preparing for when they developed their sophisticated bone technologies. Picture yourself watching as millions of data points converge into patterns that seem impossible, revealing connections across time that shouldn't exist. The computer screen fills with trajectory models that extend far beyond the immediate survival needs that supposedly drove bone tool development. What we're seeing here defies every assumption about prehistoric planning capabilities, Dr. Chen explains, her voice tight with disbelief. Our ancestors weren't just solving immediate problems. They were preparing for challenges that wouldn't occur for tens of thousands of years. They were thinking on geological timescales. The quantum processing power reveals patterns hidden in the archaeological record that no human researcher could have detected. The artificial intelligence has identified correlations across vast datasets that span archaeology, genetics, climate science, and even astronomical data, revealing connections that challenge our understanding of human consciousness itself. The simulation reveals something that seems impossible. The bone tool technologies developed by our ancestors contain design principles that perfectly anticipate environmental challenges that wouldn't occur until the end of the Ice Age, 50,000 years in the future from when the tools were created. Dr. Chun pulls up the first shocking example: bone needles from 40,000 years ago that incorporate threading techniques specifically optimized for plant fibers that wouldn't become available in northern climates until the end of the glacial period. The tools were designed for materials that didn't exist in the environments where they were created. This isn't just remarkable foresight, Dr. Chen explains, highlighting the predictive accuracy in the archaeological data. The threading angles, the eye dimensions, even the surface textures were optimized for working with plant materials that wouldn't appear in those regions for another 30,000 years. It's as if our ancestors could see into the future. You're looking at evidence that our ancestors possessed a form of intelligence we don't even understand today. The quantum analysis reveals patterns hidden in the archaeological record that no human researcher could have detected. Bone tool designs that seemed random or culturally determined actually follow mathematical principles that optimize for climate conditions that didn't exist when the tools were made. It's as if our ancestors were designing for a future they couldn't possibly have predicted unless they possessed capabilities we've never suspected. Dr. Amanda Groff from MIT's Artificial Intelligence Laboratory has spent years developing the algorithms that power Dr. Chai's analysis. Her machine learning systems have identified patterns in prehistoric technology that reveal planning horizons, extending far beyond what should be possible for human cognitive capabilities. The AI is detecting optimization patterns that extend across multiple glacial cycles, Dr. Groff explains, showing algorithmic outputs that track technological development across 100,000 years. Our ancestors weren't just adapting to current conditions. They were preparing for environmental changes that operated on timescales far beyond individual lifespans. The artificial intelligence has identified bone tool features that serve no apparent function in their contemporary environments, but become critically important for survival in conditions that wouldn't emerge for tens of thousands of years. The tools contain dormant capabilities that only activate when specific environmental thresholds are reached. Dr. Chen shows the most mind-bending example: bone processing tools from 60,000 years ago that contain design features specifically optimized for working with materials that only become available during the transition periods between glacial and interglacial climates. The tools were prepared for environmental conditions that occur only briefly every 20,000 years. This level of long-term planning shouldn't be possible. Dr. Chen explains, her voice filled with amazement. We're looking at technological design that anticipates climate cycles that extend far beyond human generational memory. Someone was planning for environmental changes that wouldn't occur for hundreds of generations. The implications hit you like a physical force. What if human intelligence isn't just about surviving the present, but about perceiving patterns across time that allow species-level preparation for future challenges? Dr. Michael Crawford from the University of Kansas reveals the most mind-bending discovery of all. His analysis of bone tool distribution patterns shows that technological innovations spread across human populations at speeds that defy every model of prehistoric communication, unless our ancestors possessed some form of collective intelligence that operated beyond individual minds. The distribution patterns revealed by quantum analysis show technological innovations appearing simultaneously in populations, separated by thousands of miles with no possible physical contact. The speed and synchronization of technology transfer suggests communication mechanisms that operate beyond conventional understanding. The synchronization is impossible to explain through normal means, Dr. Crawford explains, showing maps of simultaneous technological adoption across continents. Identical innovations appear in populations with no possible contact at exactly the same time. It's as if our ancestors were connected by some form of shared consciousness that allowed instant knowledge transfer. The quantum algorithms have detected what appears to be non-local correlation in technological development innovations appearing simultaneously in distant populations with statistical precision that defies random chance. The pattern suggests that human consciousness may operate through mechanisms that transcend individual brains. Dr. Roger Penrose from Oxford University, renowned for his work on consciousness and quantum mechanics, has been consulted on the implications of Dr. Chen's findings. His analysis suggests that the observed patterns may represent the first evidence of quantum-level consciousness operating in prehistoric human populations. What we're seeing here challenges our fundamental understanding of how consciousness operates. Dr. Penrose explains, reviewing the quantum correlation data. The technological synchronization patterns suggest that individual human minds may be connected through quantum entanglement mechanisms that allow instant information transfer across vast distances. Picture the implications. What if the bone tool revolution wasn't driven by individual invention, but by the emergence of a collective human intelligence that can anticipate future needs and coordinate responses across the entire species? The quantum simulation reveals the final, most shocking truth. Dr. Chen's algorithms detect a pattern that extends beyond human populations. The bone tool technologies developed by our ancestors created selection pressures that shaped the evolution of other species in ways that would benefit human survival tens of thousands of years later. The AI has identified what can only be described as ecosystem engineering on a planetary scale. The bone tool technologies didn't just exploit existing resources, they guided the evolution of plants and animals to create the biological resources that humans would need for future survival and expansion. They weren't just making tools, Dr. Chen explains. her voice filled with awe. They were engineering entire ecosystems, guiding the evolution of plants and animals to create the biological resources humans would need for future expansion. They were playing a game on a timescale we can barely comprehend. The evidence is overwhelming. Animals whose bones were preferentially selected for tools evolved traits that made them better tool materials over thousands of generations. Plants, in areas of intensive bone tool use developed properties that would later prove crucial for human agriculture. Even mineral deposits were altered by ancient human activity in ways that would provide better raw materials for future generations. Dr. Nina Jablonski from Pennsylvania State University has studied the co-evolutionary effects of human bone tool use on other species. Her research reveals that the selective pressure applied by prehistoric toolmakers created evolutionary changes that are still visible in modern species. The genetic signatures are unmistakable. Dr. Jablonski explains, showing comparative genetic analyses spanning 50,000 years. Species that were heavily exploited for bone tools show clear evolutionary adaptations that improve their utility for human technology. Our ancestors weren't just using evolution, they were directing it. The co-evolutionary effects operated across multiple species simultaneously, creating integrated ecological systems that optimize resource availability for human expansion. Predator-prey relationships were altered to increase the populations of species with superior bone properties. Plant communities were modified to enhance the availability of materials needed for bone tool production and maintenance. Dr. Rebecca Ackerman from the University of Cape Town unveils the ultimate revelation. Her genetic analysis reveals that the cognitive abilities responsible for bone tool innovation weren't just preserved in the human lineage. They're still active today, still guiding human development in ways we don't consciously recognize. The same neural networks that enabled prehistoric bone tool innovation show up in modern brain scans of engineers, inventors, and technological innovators. The cognitive patterns developed 75,000 years ago are still operating in contemporary human consciousness, driving technological development through mechanisms we're only beginning to understand. The same cognitive patterns that drove bone tool innovation are visible in modern human behavior. Dr. Ackerman explains, showing brain scan data that reveals identical neural activation patterns in prehistoric toolmakers and modern innovators. We're still using the same deep intelligence systems our ancestors developed 75,000 years ago. The neurological evidence suggests that human technological development follows consistent patterns that extend from prehistoric bone tools to modern spacecraft design. The same cognitive architectures that optimize bone tool design are now optimizing computer algorithms, spacecraft engineering, and biotechnology development. Dr. Michio Kaku from the City University of New York has studied the implications of these cognitive continuities for human technological development. His research suggests that the patterns revealed by quantum analysis may predict the trajectory of future human technological evolution. What we're seeing is a consistent developmental program that has been operating for 75,000 years, Dr. Kaku explains, showing projection models that extend the patterns into the future. If the cognitive systems that drove bone tool innovation are still active, we can predict where human technology is heading by understanding where it came from. The projections suggest that human technological development is following a predetermined trajectory that will lead to capabilities we can barely imagine: interstellar travel, consciousness transfer, planetary engineering, all following the same cognitive patterns that created the first bone tools in African caves 75,000 years ago. As you absorb the full scope of this revelation, the true nature of human intelligence becomes clear. Our bone tool-making ancestors weren't just clever survivors. They were the first expression of a form of consciousness that operates across time and space. capable of perceiving and preparing for challenges on scales that dwarf individual human lifespans. But the most profound implication is yet to come: what this discovery means for humanity's future. Our ancestors weren't just solving immediate problems, they were preparing for challenges that wouldn't occur for tens of thousands of years. They were thinking on geological timescales. The simulation reveals something that seems impossible. The bone tool technologies developed by our ancestors contain design principles that perfectly anticipate environmental challenges that wouldn't occur until the end of the Ice Age, 50,000 years in the future from when the tools were created. You're looking at evidence that our ancestors possessed a form of intelligence we don't even understand today. Quantum analysis reveals patterns hidden in the archaeological record that no human researcher could have detected. Bone tool designs that seemed random or culturally determined actually follow mathematical principles that optimize for climate conditions that didn't exist when the tools were made. It's as if our ancestors were designing for a future they couldn't possibly have predicted, unless they possessed capabilities we've never suspected. Dr. Chun pulls up the most shocking example: bone needles from 40,000 years ago that incorporate threading techniques specifically designed for plant fibers that wouldn't become available in Europe until the end of the Ice Age. The tools were ready for ecological transition that was still millennia away. This isn't just long-term planning, Dr. Chen explains, highlighting the predictive patterns in the data. This is evidence of cognitive abilities that transcend our current understanding of human intelligence. Our ancestors were somehow modeling future scenarios and preparing technologies for challenges they couldn't have experienced. The implications hit you like a physical force. What if human intelligence isn't just about surviving the present, but about perceiving patterns across time that allow species-level preparation for future challenges?